Welcome to SpaceVerse, your portal to cosmic adventures. A lumpy ring of interstellar dust hides what little star formation the Sombrero has to offer. The James Webb Space Telescope's brand new image of the Sombrero Galaxy casts this city of stars in a new light, mid-infrared light to be precise, and reveals clumps of dust in a mottled outer ring. The Sombrero Galaxy is so named because in visible light images lying nearly edge onto us, it bears an uncanny resemblance to a sombrero hat, with its wide rim and bulging center. It's one of the most iconic galaxies in the sky, a symbol of cosmic structure and symmetry. But when seen through JWST's mid-infrared instrument, or MIRI, the entire identity of this galaxy shifts. What used to be a graceful central bulge now nearly disappears. MIRI has the unique ability to peer through clouds of gas and warm dust, giving us a vision far removed from what we're used to in visible light. That classic sombrero shape? It vanishes, replaced by a lumpy, fragmented ring of cold dust, circling a dimmed but still brilliant core. That glowing core is more than just a stellar centerpiece. Deep inside, it houses a supermassive black hole, a quiet giant in the current cosmic era, but one with a powerful, turbulent past. The Sombrero lies about 31 million light-years away in the constellation Virgo. It's cataloged as both Messier 104 and NGC 4594. But it's not just another galaxy among many. The Sombrero is the most massive spiral galaxy within 100 million light-years of Earth. That's a pretty big title. All its stars combined weigh in at around 260 billion solar masses. That's nearly 5 times the mass of all the stars in our own Milky Way. With a mass that enormous, you might expect a frenzy of star birth, stellar nurseries glowing with young blue stars, and the chaotic brilliance of stellar formation. But that's not what we find. On average, within the Sombrero, only half a solar mass of gas is converted into stars each year. Compare that to the 1 to 2 solar masses per year in the Milky Way. So despite its grandeur and size, the Sombrero forms stars up to 4 times more slowly than our galaxy. Stars, as they die, produce dust. That dust drifts, clumps, and often gathers around regions where new stars are forming. That's where MIRI's true capability shines. It cuts through the galaxy's visible starlight and instead detects the colder, darker dust, the remnants of stars long gone, and the scaffolding for stars yet to come. And that's why, in this new image, the iconic bulge is gone. What dominates instead is the Sombrero's dust-rich outer ring. It's intricate, full of wispy clouds and subtle features. A celestial fingerprint of past activity. MIRI's observations even caught the telltale signatures of polycyclic aromatic hydrocarbons, or PAHs, large carbon-bearing molecules commonly found in star-forming regions. These molecules are important. They're like cosmic smoke signals, marking areas where stars could be born or once were. But there's a catch. Dust alone isn't enough to form stars. You need cold molecular hydrogen gas and lots of it. That gas can be insulated by the surrounding dust, keeping it cold enough to collapse under gravity and spark the formation of new stars. Yet the star formation rate in the Sombrero tells a very different story. There's not much molecular hydrogen left. So where did it all go? Astronomers believe the answer lies in the past. The large bulge seen in visible light likely formed during a massive starburst event many billions of years ago. During that event, the galaxy rapidly burned through its raw materials, turning gas into stars in an explosive era of creation. That surge exhausted most of its fuel, leaving behind only enough gas to sustain a modest trickle of star formation, mostly confined to the outer dusty ring. In a way, what we're seeing now is the afterparty. The intense cosmic dance of creation has ended, the music has faded, and the once bustling stellar nursery now echoes with the quiet hum of slow, aged processes. Interestingly, despite its location in the sky within the Virgo constellation, the Sombrero is not part of the Virgo cluster of galaxies. It's actually around 25 million light-years closer to us and resides in a relatively empty region of space. This isolation matters. Galaxies like our Milky Way have neighbors, the Magellanic Clouds, Andromeda, Triangulum, and they're all gravitationally interacting in some way. These interactions can stir up gas, provoke star formation, and even awaken central black holes. But the Sombrero? It's been alone for a long time, and that solitude has had a profound effect on its evolution. In more densely packed regions of space, close encounters between galaxies can send gas and dust spiraling into galactic centers. There, they feed the supermassive black holes, which consume the matter chaotically. This activity turns them into active galactic nuclei, or AGNs, incredibly luminous objects that can fire out jets of high-energy particles at near light speeds. But the Sombrero shows no recent evidence of such encounters. No cosmic collisions. No wild feast for its black hole. At least, not for billions of years. That said, the black hole at its center, which weighs in at around 1 billion solar masses, wasn't always so quiet. Earlier in 2024, astronomers using the Very Large Array of Radio Telescopes in New Mexico made a stunning discovery. They detected huge lobes of radio wave-emitting particles, stretching 30,000 light-years on either side of the Sombrero. These lobes were created by powerful jets that once blasted from the galaxy's AGN, a clear sign that the black hole was once very active. How did it get that fuel? One theory is that a giant intergalactic cloud of gas may have fallen onto the Sombrero long ago, providing the raw material needed to spark AGN activity. Even though the galaxy is alone now, it may have once interacted with something massive and invisible, a relic of a bygone era in deep space. Today, though, the Sombrero's black hole is practically dormant. The jet it produces now is only a few light-years long, a faint whisper compared to the ancient roar that once echoed through intergalactic space. This was observed with the Very Long Baseline Array, a network of radio telescopes spread across the United States. So where does that leave us? We're witnessing the twilight of a titan. All that brilliant star formation, the dynamic black hole activity, the wild cosmic growth, it's all happened long before we arrived to observe it. The Sombrero Galaxy is now in a quiet phase of its life, its partying days long gone, the memories of those times hidden in the dust and relics of the past. It sits lonely in deep space, relatively safe from collisions, slowly aging with grace. And in this stage of cosmic serenity, it offers us not just a lesson in galactic evolution, but also a glimpse of what our own Milky Way might look like in the far future. Thanks to the James Webb Space Telescope, we can see this galaxy not just as it is now, but as a layered record of all it's been through. The visible light showed us beauty. The infrared light now shows us truth. A truth written in dust, in silence, and in the long, slow exhale of a galaxy after the fireworks have faded. And that's it. If you enjoyed this deep dive into the Sombrero Galaxy's quiet legacy, make sure to subscribe to SpaceVerse. The cosmos is vast, mysterious, and ever-changing, and we're here to explore it one story at a time. Until next time, keep looking up. The universe is waiting.